All right, welcome to chemistry. Some of you out there, you may never have had chemistry class. This is the only way you're learning it. Well, then this is going to start your voyage through chemistry. Those of you who have had me in class, well, this is a review. Let's start with, what is chemistry? Why are you here? You're here to study chemistry, which is the study of matter and how it changes. Well, then what does matter? Matter is anything that has mass and takes up space, has volume. Almost everything we can sense is matter. The only exceptions are those things like light and heat, which are pure energy and do not have any mass. Now, what's matter made of? Most chemistry courses start with this, at some point teach you the history of atomic structure. I generally choose not to do that. If you're interested in it, or if you're doing this for another teacher who says you should do it, there's another lesson in this chapter on the history of atomic structure. You should refer to that. We're going to start about 1910, and 1910, 1915, somewhere in that vicinity. So at that point, based on the work that happened before that, we determined that the smallest unit of matter, smallest piece of matter, is an atom. And then atoms are used to form larger things by combining into combinations of atoms and other things to form compounds and molecules and whatever. And we'll talk about that all throughout the year. But anyway, an atom has three components: protons, neutrons, and electrons. But you probably knew that. Now, what's an atom look like? Protons and neutrons are both located in a very tightly packed core in the center of the atom called the nucleus. And electrons go around the outside of the nucleus in what we call a cloud, and they're moving nearly the speed of light. Now, because electrons are free to move, they're not stuck inside a nucleus they're being held on very tightly. Electrons can be exchanged or transferred or shared, and this is what happens to make different compounds and chemical reactions, and that's going to be the basis of what we do in this class this year. Now, so three subatomic parts: protons, neutrons, and electrons. Importantly, what you need to know: one, protons are positive, electrons are negative, and neutrons have no charge. That's the most important thing. Now, there are masses in kilograms. That's a tiny, tiny number. You don't need to know that. What you do need to know is basically protons and neutrons essentially weigh the same thing. And then electrons are 2,000 times less massive, and therefore when we're figuring the mass of an atom, we don't care about the electrons. They're just noise in the system. So, and for our purposes, we consider the mass of a proton and a neutron to be 1 unit or atomic mass unit. Electrons are 0. Okay. First question of the year. What kind of charge does proton have and electron have? You better know this, because we just went over it. The answer, of course, is C. Protons are positive, start with a P. Electrons are negative. Now, neutrons, protons, and atomic mass. Atomic mass is representative of the mass of an atom. Since electrons are so small, we don't care. So to figure out the mass of an atom, we add the number of protons and neutrons, giving each proton and neutron a mass of 1. So therefore, to find the mass of an atom, the atomic mass, you take the number of protons, add it to the number of neutrons, and you'll get the atomic mass. Now, take a look at your periodic table. In the periodic table, you see information on each element. Take a look here at uranium here on the right. The 92 is called the atomic number. The atomic number shows a number of protons and, in this case, the number of electrons. Since atoms are neutral, the pluses and the minus balance out. And so the charge is neutral. So the protons and electrons. We're going to get to ions, which are charged atoms, but that's not till chapter 3. So until we get to that, for not right now, all atoms are neutral, so the number of protons equals the number of electrons. The number of neutrons is different. Neutrons are neutral, so that the charges don't have to balance or anything. So you'll see on the chart, if you look at uranium, 92 is the number, the atomic number, that's the number of protons. Atomic symbol and name. Atomic symbol is U, uranium. Some periodic tables won't have the name, will just have the symbol. You don't need to memorize them, but you'll get to know a number of them commonly in the not too distant future. Finally, at the bottom is the atomic mass. You see the atomic mass written as a decimal, which doesn't agree with what I just told you about using 1. Well, what happens is these are averages of all the different known what are called isotopes, which you're going to learn about in chapter 3. It's an average. So that's what appears on the periodic table. Some teachers make you use that number. What we will use in our class is we will round the number to the nearest whole number. There are a couple of exceptions to that, and we'll go through that when we get to that point. But basically, for all of our calculations, we will use rounded whole numbers for the atomic masses. So, for example, hydrogen would be 1, and uranium would be 238. Okay. Not a word I use a lot, but protons and neutrons are called nucleons. Now, to find the number of neutrons, since we know that the number of protons plus neutrons equals the atomic mass, therefore the number of neutrons will equal the mass minus the number of protons, or the atomic number. All right, let's go through some sodium questions and then see if you got it. All right, so what's the mass number? This is a way that sometimes it's shown. You can see two numbers. Sometimes I put them in different places or whatever. But what do those two numbers represent? Well, the mass number is 23. Protons plus electrons. How many protons do we have? Protons are represented by the atomic number. So the number of protons would be 11, would be B. How many electrons does sodium have? Since it's a neutral sodium atom, the number of protons have to be the same as the number of electrons. So the answer is B, 11 again. How many neutrons doesn't sodium have? This one requires some real tough math. It's called subtraction. We know there are 23, the mass number is 23. That is the total number of protons plus neutrons. We know the number of protons is 11. So to find neutrons, we simply subtract the atomic number from the mass number, 23 minus 11. We get 12, and the answer is C. All right, how many neutrons in bromine? Bromine, mass number of 80, atomic number 35. 80 minus 35 equals 45, so the answer is C. One last question real quick. The mass of a proton is about how much more than that of an electron? I mentioned this earlier, that the answer is around 2,000 times. Okay, you have a bunch of practice problems. Basically, you got to find some answers, things like that. Go through the problems. If you don't understand a question, you're doing this remotely, send me an email. I'll go over it, or we'll go over it in class. Maybe we'll do something else online. It all depends on where we stand. These videos could be used for a long time. So anyway, if you don't understand something, always ask a question. All right, congratulations. You have finished your first chemistry lesson. Only about 150 to come. You're gonna like it.